Good day, everybody. And once again, we are back together. And this time, we're looking at question number 7. As I said, that this question paper was recommended by Naledi, who has asked us to answer these questions. So let's get right into it. So they say to us, consider the cells represented by P, Q, R, and S, and which are graphite electrodes. All right. So definitely this is an electrolytic cell, right? Now I want you to note they've given us an electric power source there, all right, which makes our electrodes positive and negative respectively. Right, now firstly, I want you to note that in the first electrode, they've given us saturated magnesium chloride, okay, and whereas in the second one, they have given us saturated, or rather dilute, magnesium hydroxide, magnesium chloride rather. So I'm so used to saying magnesium hydroxide. So in this case, two types of reactions are in fact going to take place, right? And I want you to think about it. And I'll explain even further the reasons before that. And I'll show you from the standard reduction potentials table, right? So when you look at this one, because we've got saturated magnesium chloride, then what's going to happen is that the Cl minus ion, right, will undergo oxidation. So that will happen at electrode P, right? So in this case, you're going to have Cl minus, all right, simply becoming Cl2 by giving away 2 electrons. Now, where you will see this reaction, and I tried to make it as convenient as possible so that we are able to see that. So that's the reaction that takes place over there. Now, the reason for that is that we've got chloride ion, okay, and it is a very strong, it's a very strong oxidizing agent in that case, or you can even say it's a much weaker reducing agent, right? So as a result, it will tend, in this case, to undergo that reaction. Now, in this case, I just wanted to show you what happens in the other reaction. Now, I want you to note here, we've got dilute magnesium hydroxide, which means what is dominating there is water, right? So in this case, you're going to have, in a sense, the autoionization of water. But what you're going to have now is you're going to have H2O undergoing oxidation in the one instance and undergoing reduction in the other instance, right? So we're going to talk about what those reactions look like respectively, but let's answer the questions that are asked. They say, what type of electrochemical cell is represented by X and Y? That's definitely going to be an electrolytic cell. Okay. Right. Now, the next question says, circle the correct word within the bracket. In this type of cell, reduction takes place at you know that it will take place at the negative electrode. That's the one that's going to supply us with electrons, and those electrons would cause reduction to take place, right? Okay, so the next question says, the chemical substance that forms, or rather the chemical substances that form preferentially at Q and S are the same, all right? So they are leading us there, right? Identify these products. Right, now you'll notice at Q and S, this is where we've got negative, we've got our electrons there that are supplied by the cell, right? Now, in a sense, I want you to note the saturated magnesium chloride. We did say chlorine is formed on this one. However, here we are going to now form different products, and I want you to see it, okay, on our reduction potential table. Right, so what we are going to do is take H2O, right, and what it does is it undergoes, I'm just trying to look for that reaction. Yeah, there we go. Okay, so in this case, you've got H2O, here it is, right? Undergoing reduction, in this case forming hydrogen and the hydroxide ion, right? So, which means that we are going to have as products on both P and Q. Remember, we said that it is undergoing reduction, it's gaining electrons, so you are going to have H2 as well as OH minus hydroxide ions. If you want to, you can write down the 2 there just to show that it's 2 hydroxide ions. So these are the products that are going to be formed at Q and S respectively. Right, now they say to us the solubility of magnesium chloride hydrate, right? So which means this is a hydrate in water at 25 degrees. That is the maximum amount that will dissolve is 55 grams per 100 cubic centimeters. They say calculate the molar concentration of the chloride ions in the saturated solution in cell X. Right. Now they've given us all the information that we need, right? So firstly, they've given us the mass, okay? So here it is, all right? And then secondly, they have given us the volume, right? Which is the volume of water. Now what we will need to get, because we want the concentration there, and remember I said to you, whenever we are looking for concentration, given the mass, we can say concentration is mass divided by molar mass times the volume. Right, so let's do that quickly. So our mass is 55, okay, and our molar mass. Now note, we've got magnesium, we've got chlorine, and we've got that hydrate over there. Now please, I want you to note, let's go to our periodic table, right? So there's magnesium. And of course, I'm mindful I'm using the one from DBE. It might be different from the one that you use in IEB. So we've got magnesium, we've got chlorine, and we've got hydrogen, and we've got water, right? So let's calculate there. So we said magnesium, I just circled it, that's 24. Okay, so that's 24 plus, that's chloride. That's 2 chlorine atoms there. So that's 2 times 35.5 plus. Now, I want you to note in this case, we've got 6 times H2O. So this is plus 6 times. H2H is 2 times 1 plus. In this case, we've got O, which is 16. Right, and remember all of this is multiplied by the volume, and our volume is in cubic centimeters. We need to get it to cubic decimeters, so that is multiplied by 0.1. Right, now let's go for it. So we've got 55, that's divided by, we've got 24 plus 2 times 35.5. Okay, this is plus 6 times. Okay, I'm just going to add those up together. So that's 18 for water. All right, and I'm going to close that bracket. And this is multiplied by 0.1. All right, and I get the concentration to be 2.7. Okay, that's let's say 2.71 moles per cubic decimeters. Now, ladies and gents, I want you to please be very careful here, because we are not asking for the concentration of magnesium chloride, right? But they were looking for the concentration of chloride ions. Now, what do you notice? When the magnesium chloride, okay, ionizes, or rather dissociates, it will give us magnesium 2 plus will have 2 chloride ions that are formed there, 2Cl minus. Okay, so which means for every 1 mole of magnesium chloride, I've got twice the number of moles of chloride ions. So therefore, it means that the concentration of our chloride ions will therefore be 2 times the concentration of magnesium chloride. So that's 2 times 2.71 moles per cubic decimeters. And so that will give us, that's going to be 5.42 moles per cubic decimeters. Right, and that's how the cookie crumbles, ladies and gents. I hope that makes sense. Right, so that's the amount of magnesium chloride, the chloride ions. Right, now let's go on to the next question. They say the chemical substances that form preferentially at electrodes P and Q are different. Identify these substances, use the standard electrode potential to assist. Now, this is exactly what I was explaining earlier, right? That here you've got saturated magnesium chloride. Okay, so there's very little water that you've got there. Right, so now what happens over there is that the chloride ions, right, now would become chlorine. So which means at electrode P, you're going to form chlorine over there. So this is Cl2, okay? But now let's look at R. Or rather, let's look at R. What happens at R? So this here, we know that water undergoes, in this case, oxidation, right? So I want you to note there is a reaction that shows us the oxidation of water. I'm gonna go to it quickly. Let's see there. Okay. Where water undergoes oxidation, the loss of electrons. Okay, there we go. So this is the reaction. Okay, so the reaction that takes place over there is that water undergoes oxidation and forms oxygen and, in this case, hydronium ions, right? So you are going to form oxygen as well as hydronium ions. And in this case, this is an oxidation type reaction. Okay, right, so you've got O2, okay, as well as 4H plus. Right, even if you just said O2 and H plus, I think that would still be okay. Right, now they say to us, refer to the cell conditions to explain why different products form at electrode P and R. Right, and please guys, I want you to follow in this because I really want you to get this, right? So I want us to start with what happens at R. In fact, that's the one that's the most interesting, right? So what do we have? We've got magnesium magnesium chloride, right? That is, okay, let's go back there. Okay. All right. So we've got magnesium chloride. Firstly, let's start with R. Okay, so you've got H2O as well as magnesium chloride. Okay, but what happens in this case? Magnesium chloride, or rather let me say H2O, has a stronger reducing agent, or is a stronger reducing agent than the chloride ions. And this you can see from your table, and I'm going to show you in just a bit. Anytime that you look at this table, right? So I've just shown you the two reactions there. So where is reducing agent? There it is. Okay, right. Now, when you look at it, ladies and gents, please, I want you to note, it means the lower I go, the stronger it becomes as a reducing agent, right? So H2O is a stronger reducing agent in that case than the chloride ions. Okay, so it will tend to undergo oxidation, right? So let's explain that part. Okay, remember, the stronger it is as an oxidizing agent, then it means that it prefers to undergo reduction. But the stronger it is as a reducing agent, it means that it prefers to undergo oxidation, right? So we've got H2O, right, which is a stronger reducing agent than H2O. Okay, right. So in that case, what did I say there? That sorry, as I wanted to say than Cl minus, than the chloride ions, right? So it is a stronger reducing agent than the chloride ion. So therefore, it means that we will undergo, therefore, it undergoes oxidation. Will undergo oxidation. Okay, right. And now this is in relation to what happens at R, right? And that's why we had that reaction taking place. Now, in this case, when we look at the other reaction, right? So we've got a highly saturated magnesium chloride solution, right? So in this case, when the concentration of the of our chloride ions is very high, right? So the rate of the oxidation reaction in this case will increase, right? So because you've got concentrated magnesium chloride, it means there is a higher rate of reaction that is likely to take place in this case. Okay, so as a result, that's why we are going to have a chloride ion being oxidized in this case to form chlorine, right? So, okay, so we're going to say the higher the concentration of chloride ions, right, in the cell, the greater the rate of reaction, right? The rate of reaction. So therefore, it means that the chloride ions will therefore undergo oxidation. So Cl minus will undergo oxidation, right? And that is the sole reason. Otherwise, the same reaction would have happened, but because you've got a much higher concentration there, remember, the higher the concentration, the greater the rate of reaction. Okay, right. So as a result, that is why we're going to form chlorine in reaction P. Okay, right. So that's why we're able to form chlorine over there. Right, and then let's go to 7. Let's see the next one. Now they say to us, consider cell Z, okay, Z for some of you, shown below, in which T and U are also graphite electrodes. Right, now they want us to define an electrolyte. So remember that an electrolyte is a substance that conducts electricity when dissolved in solution, right? Or you can say to us it's a substance that dissolves electricity due to the movement of ions in solution. Okay, right, now let's go to the next portion. I'm not going to write that one down. They say explain briefly why a much higher temperature is needed in cell Z. Okay, so what are they trying to do in cell Z? So in this case, I want you to please note that when you are trying to convert magnesium chloride, remember it's molten, and in this case I'm presuming that it's at a higher concentration. Remember that the type of bonds that there are, this is an ionic bond, which means that it would have a much stronger, it would need more energy in order for you to be able to separate the molecules, right? So you must note that a magnesium chloride is made out of ionic compounds which require a higher energy to separate. Okay, or you can say it requires more energy to melt. Okay, that's what a melting point actually means. Right, now they say to us, identify the chemical substances that form. Now, in this case, ladies and gents, because you've got molten magnesium chloride, okay, what happens to the magnesium chloride? It will first break down into magnesium 2 plus and Cl minus. Now notice in this case that the Cl minus, right, will now undergo oxidation, okay, the loss of electrons, and which means now magnesium plus ions are going to undergo reduction. Okay, so what am I going to form in that case? So which means the two reactions that are going to take place, that's Cl minus, which gives me Cl2, so I'm still forming chlorine at electrode T, and which means at electrode U, I'm going to have magnesium 2 plus gaining electrons and forming magnesium. Okay, so I now have got at electrode T, right? So I'm going to have Cl2, and at electrode U, I'm going to have magnesium. Right, and essentially, ladies and gents, that brings us to the end of question number 7. Just note those different states, the molten, secondly, the concentrated, as well as the dilute magnesium chloride, because it will determine the type of reaction that we have. All right, so we are going to move on to question number 8. We are almost at the tail end of this question paper, so please look out for that. For now, I'll see you guys next time as you prepare. I wish you all of God's best. Sharp, sharp.